Okay, you're welcome back to Integrated SSS Mathematics. Uh, Today I'm gonna continue the last session that's the Jacobian matrix related to the uh, cylindrical coordinate system. Let's see how the calculation is going on. Okay, here I have stopped by the Jacobian metric, the determinant of the Jacobian metric. Let's see today uh, how this can be applied for any of the application. Okay, let me show you the oh my god, it started to rain. Okay, uh, the determinant of the Jacobian matrix. Just you're able to simply you are able to calculate the determinant of this matrix. This is called as Jacobian matrix, and this is the uh, you are able to apply the properties of the determinant of any matrix form. Okay, just I eliminate the last row and the last column, and it comes as the determinant of the Jacobian matrix is going to be equal to rho. Okay, means this can be written as dx dy dz is going to be equal to rho times d rho d theta dz. Okay, let me show you at what time we are able to use this type of conversion. Okay, honestly, when we are going to evaluate any of the volume that's related to the cylindrical coordinate system, we are able to apply this. Okay, after this we have to talk about the spherical coordinate system also. So here I'll give you an example. This would be very profitable, very useful for you when you are dealing with the statistical operators. Okay, here you have heard about this. If you know, if you have really knowledge about the statistic, this guy, we I used to call this as normal distribution, and the Gaussian distribution also. That's why this is called as Gaussian distribution, because we need to evaluate the volume under the curve, the curve, the function. This is the fx, the function of x. This is equal to the e to the power minus uh, times x minus mu. This is nothing else. Mu is the normal of the population. Okay, or 2 times variance over the standard deviation time, the square root of 2 pi. Okay, this is a function. If you guys need to evaluate the probability during any of the interval, bunch of interval, you need to evaluate the probability. What you need to do is you have to get the integral of both sides. Okay, I get the integral of both sides. This guy becomes px. I'll say I'll say him from minus infinity to plus infinity. It means this should be equal to 1. Okay, this should be equal to 1. Okay, it's like this, from minus infinity to plus infinity, how this integral should be evaluated. Okay, this type of integrals are called as something Gaussian integrals. That's why this is called as Gaussian, because the we need to because this is related to the normal distributions. Okay, by using a normal path, usual path, yeah, you are not able to with this guy, so you need to uh, rotate the function about the z-axis. Okay, you would be seeing this type of solid guy. This type of solid guy. If you rotate it about the z-axis, I try my best when I'm figuring out. Okay, this is the z-axis. This is the z-axis. This is x, y. Okay. Let me show you guys why I am rotating this about the z-axis. Okay. If you guys assume that this is equal to I, this is the I square. Let me show you how it's coming. This is from minus infinity to plus infinity e to the power minus x squared dx. Okay. What would happen if the power is going to be just like this, e to the power minus x square plus y square, the double integral. If you get the double integral of this from minus infinity to plus infinity, the lower boundary of the y is going to be equal to from minus infinity to plus infinity. Here too. Okay, you are able to separate this as so I have no space. I used to start it by here. So it can be written as minus x from minus infinity to plus infinity dx times from minus plus infinity e to the power minus y square dy. You would see that what would be happening. Okay, if we guess that this is equal to I naught, what would be happen to I naught? This is I naught is going to be equal to I square. Okay, this is the inside of this. Okay, the fantastic simplification that's hidden inside of the particular integral. Okay, so if you guys are able to evaluate the I square, it means you are able to get the square root of them and evaluate the I naught. Okay, hope you guys could understand all of these stuff. If you have any of the doubt, please be kind enough to put a comment. Okay, I'm gonna continue the integral part. Okay, let me erase these things. As this, let me show you. I'm trying to figure out and I'm trying to explain all these very briefly. Okay, I'm not gonna explain all this by each of the steps, very simple steps. Okay, here what will happen when you have the integral, when you let the double integral, what will be happen? Let me show you. So e to the power minus x square plus y square dx times dy from minus infinity to plus infinity, from minus infinity to plus infinity of Latin it. Okay, so I'm having a substitution. Substitute as x square plus y square is going to be equal to r square because I apply here at this moment the cylindrical coordinate system. If you pay much attention on this, if you pay much attention on this disk, what will happen if this is the r? Let me call it this as rho because I have denoted that as rho and previous session. So if you guys call this as rho, what would happen to the x? This can be written as x square plus y square is going to be equal to rho square. Okay, so what would happen to this guy? The e to the power minus x square plus y square can be written as z. This is z. Okay, z is a function of x and y, both x and y. It means it has a three-dimensional figure. It's like this is a solid. Okay, if you rotate your Gaussian distribution, if you rotate your normal distribution around the z-axis, you would have a solid surface is like this. Under this surface, the volume is going to be calculated. Okay, this is the height. I use another color. Okay, here this is z. This can be evaluated by using triple integral also, but this at this moment I'm gonna evaluate this using cylindrical coordinate system, because we were discussing about the cylindrical coordinate system the very first. Okay, let me show you guys. Here I replace this as rho. Okay, rho square. Here you remember that dx dy times dz is going to be equal to rho times d rho d theta dz. Okay, so we are able to write down it. We are able to replace dx dy by rho times d rho d theta. Here you would have a double integral just like this. Okay, most of the times you would be panicked. You'd be panicked of this. Actually, what happened to the dz term of dz? Here, we don't have any dz term. Here too, we don't have any dz. What happened to the dz? Actually, what would happen to dz? I'll show you by figuring out the geometrical way of this. Let me show you the geometrical way. Let me erase this and draw a nice figure more than this guy. Okay, so I'll use blue color at this moment. So this is in three-dimensional Euclidean plane. So you'd have this type of figure. I'd like to show you a disk, only disk. Just pay much attention on this disk. Okay, there's a segment. This is the center here. This is the arc. This angle is going to be equal to d theta. This is a rho. Okay, the arc can be written as rho d theta. Okay, if you guys feel a very little bit, very tiny area from the solid body, very tiny molecule. Okay, what would happen? This is d rho. This is d rho. That's measured along the rho direction. This is going to be, oh my god, you would not be seen. I'm sorry. So here I have to do more clear one, because we are working with very less percentage. I'm very sorry about that. This guy is dA, very tiny area. So this can be written as d rho times d theta. You guys will see this, how the rho comes, okay. But I need to look the, actually I need to read the volume. So I filter out the I figure out very little, very tiny molecule from the whole body. So this can be written as dz. If you guys need to evaluate the dv, this is going to be equal to rho times d rho times d theta times dz. How dx times dy times dz is going to be equal to rho times d theta times dz. Okay, so what would happen to the dz term here? Here actually we have evaluated that. Let me show you. I'll use another color. If there is the other term also z, that's called z, what would happen? Okay, dz. So dz should be integral from evaluated from 0 to from 0 to this much. This much mean e to the power minus z. this is equal to e to the power minus x square plus y square minus times. Okay, so x square plus y square is going to be equal to rho square. So this is going to be evaluated from 0 to e to the power minus rho square. Okay, so it becomes here when you evaluate this guy, it becomes just e to the power minus rho square. How it's being vanished? Okay, how it's being vanished? Is like you guys are able to evaluate the volume and get the square root of both sides, and you are able to evaluate the I. That's the area under the curve, under the normal distribution, under the Gaussian distribution. That's how we use the Jacobian, the determinant of the Jacobian matrix for calculating the probability. Okay, this is one of usages you need to use when you're dealing with the statistical. If you guys have any of these scientific calculator, that would be very easy to calculate that. So I encourage you to use this kind of thing. Otherwise, on the other hand, you're able to use this for determining the way for calculating the density, just like that, volumes, kind of thing. Okay, by the next video I have to continue this part. That's the we are gonna calculate the, we are gonna find out the del operator, okay, the del operator that's related to the uh, that's related to the cylinder coordinate system. Hope you guys could understand all these stuff. If you have any of the doubt, please be kind enough to put a comment on this video. So hopefully go through our videos. Okay, thank you for watching.